Okay, power functions can be written in the form f of x equals k times x to the a, right here, where k and a are non-zero constants. So those have to be numbers, and they can't be 0. And that makes sense because if k was 0, this whole thing to the right would become 0, and you would have the 0 function. If a was 0, the x to the a would cancel to a 1. It would just be f of x equals k, which is the horizontal line. So k and a have to be non-zero constants. They cannot be variables. And that would give you a power function. A is going to be the power, and k is the constant of variation, or it's sometimes called a constant of proportion. Okay, so we will say that f of x varies as the eighth power of x, or proportional to the 8th power of x. Okay, so that's power function. It's a power function if it has a power of some sort. And whatever the coefficient is the constant of variation. All right, easy enough? So if I wanted to write this power function, a whole bunch of words, blah, blah, blah. From empirical evidence in the laws of physics, it has been found that the period of the time of the t for the full swing of the pendulum varies as the square root of the pendulum's length. So we're going to write that as an equation. So time varies as soon as you say varies as, you would just say equals k. If it varies directly, it's going to multiply to, and it says the square root of the length. And that's how you would write that. Time varies as, so you have to have that k, the square root of L. Now k could be 1. All right? Yes, sir. So we're going to write this. So anytime you're given a radical, you're going to rewrite that. You need to know that the exponent in rational form is 1 over 2. So remember, square roots are a power of 1 over 2. So if you were to ask what the power was, you would say 1/2. And the constant of variation would be k. Make sense? Let's try another one. So there's a question that basically says this. What's the power and what's the constant of variation? Okay? So the area of an equilateral triangle varies directly as. So the area varies directly as the square of the length s. So it would be s squared. And that's it. Nothing crazy hard. Okay? Now the trick today is being given a power function and being able to graph it without your calculator. And that's what we're going to learn. And there's a whole bunch of combinations of powers we can write. Okay, whole numbers, fractions. Fractions that are greater than 1, fractions that are less than 1, negative numbers. And a whole bunch of things we can do for powers. So, here we go. We already talked about that. K is the constant, and n is a monomial function. So anytime you have n being positive, the exponent being positive, it's a monomial function. Okay? A binomial would be like x plus 2. This is monomial. Okay. So when k or n is a positive integer, a whole number, if you will, we already know how to graph these. What if the exponent is a 2? What's the graph look like? Yeah, it's just a quadratic, right? What if the exponent was a 3? What would the graph look like? A cubic. What if it was a 4? Looks like a quadratic again. What if it's a 5? Looks like a cubic again. 6. So if it's an even exponent, it looks like the quadratic. If it's an odd exponent, it looks like the cubic function. Those are whole number guys, okay? if k ends up being, so if I have kx to 2, looks like this. Kx to the 4th looks like this. Kx to any even exponent, it looks like this. What if k is negative? What happens to the graph? It flips it upside down. Okay? So if my x is a cubic, it looks like this. And again, doesn't matter, any x to the odd, it's going to look like this. But if it's an x to the negative odd, it's going to flip upside down. It looks like that. Okay, so you know those things. You should know those things already. Okay. The power function is when a can be anything, a fraction, integer, any of those. Okay. So when x, and we're going to talk about all these. I like it better if you have square roots. So we're gonna jump in. Okay? This is a little crazy looking. Okay. If the exponent is a 1, guys, we just have k times x, which is a straight line. Okay, that's that black line. All right. If the a, and I just would write these separately. If a is a fraction bigger than 1, we are only looking at one quadrant here. If a is a fraction bigger than 1, or a whole number bigger than 1, it looks like this. And you have that arm of the parabola, or the cubic, right? It looks kind of the same. If the a value, if that exponent is between 0 and 1, you have this swoop, like a square root function. Okay, it starts and swoops to the right. If the exponent is negative, you have this green branch. So I would maybe draw those separately. Okay, so let's kind of draw them separately down here. If k, I don't care about the 1. If k is greater than 1, you have this curve. Okay. If k is between 1 and 0, you have this curve. If k is less than 0, you have a branch. Okay? And if k is 1, it's a straight line. Now, understand, that's the first quadrant. Quadrant 1. If I'm using the wrong variable, don't yell at me. Those are all a's. Just erase. That's why we use pencils, guys, because we all make mistakes. So when your exponent is greater than 1, exponent's between 0 and 1, and the exponent is negative, you have those guys. If the k is negative, what happens? If that front number is negative, what happens to all of these guys? They flip. So a negative one here, for a negative k, a is still greater than 1, but it's a negative k. It looks like this. Right? This guy with a negative k would look like this. Or if I have a negative k and a negative exponent, it looks like that. So your goal is to be able to graph either the first quadrant or the fourth quadrant. And then we're going to worry about the other side when we look at another piece of the equation. Okay? So just looking at the exponent. If it's bigger than 1, you're going to have a branch, an arm, I should say, like a quadratic or a cubic in the first quadrant. If the exponent's between 1 and 0, a fraction less than 1, but still positive, it looks like the swoop of the square root. And if it's a negative exponent, that means the x is in the denominator, which means we have asymptotes. And it causes a branch. Okay? Everyone with me? First or fourth quadrant if you have a reflection. Let's look. Here we go. How would I write cube root of x with a rational exponent? 1/3. So we are going to start, it's positive, so we're going to worry about our first quadrant. How is it going to look? I'll give you some choices. A, B, or C. Which way does it look? B. It looks like this. That's my first quadrant. Okay? So we are just looking at the A value. Now we're going to pick it apart. Which of those numbers, this fraction, which of them represents the root? The top or the bottom?
These ones are good. Just in case.
Yes. Top or the bottom? What's the root? Look up here. What was the root? It's a cube root. This is how I remember it. If I'm a tree, where are my roots? At the bottom, right? So when you're looking at a rational exponent, the bottom's telling you the root. So look at this root. If it's an odd root, you have stuff on the left. If it's an even root, the domain starts at 0 and goes to the side. That's just how it is. If you have a rational exponent, if the bottom is an even root, you cannot take the square root of a negative number. So negatives don't exist for even root functions. Okay? So this is an odd root. So we have things on the left side. The domain is all reals. All right? What we have on the left side can be figured out by the top. The numerator. If it's odd, you have an odd function. Remind me, with an odd function, what's going on with the graphs? In an odd function, the graphs, are they reflections or are they rotations? They're rotations. So this side is going to look like this, because it's a rotation around the origin. Does that make sense how we graphed it? You have to pick apart that exponent, one piece at a time. Okay? Let's look at this guy. And I'm not saying these are easy, they're far from. We're going to write this as 3x to the negative 2. If the x is in the denominator, when you bring it up, that means it's a negative exponent. If I have a negative exponent, what does that mean for my graph? Does it look like this? A, B, or C? C. It's that branch. It has asymptotes. The x is in the denominator. That tells me there's asymptotes. I can't touch the x or the y-axis. Okay? So if you look at that as a fraction, negative 2 over 1, it was negative, so I have a branch. The bottom is an odd number, which means there's something that exists on the left side. Right? Where am I going to put the other branch? Is it going to be reflected or rotated? The top number is even. This guy is even. So I have to reflect. It's going to look like this. If you have the first quadrant, the right side figured out, you can figure out the left side. Okay? We're going to do a lot of these guys. This is just the very start of this. We're going to do bunches and bunches. Okay, hopefully you'll start seeing it. Okay.
This will be on the quiz.
This is on the quiz, yes. Okay? All right. Yes, sir.
Is it flipped because of the coefficient?
Because of the 2.
2. Okay.
This 3 has nothing whatsoever to do with anything. The only time this is going to affect, the 3 is going to affect anything if it was negative, and that would be flipping everything. Okay? So you're looking at this negative 2 over 1. The 1 is odd, which means I have something on the left side and the right side. The top number tells me what I'm going to do on the right side. Am I going to reflect it if it's an even number? Or I'm going to rotate it and put the other branch on the left bottom third quadrant. Okay? So let's try another one. And we're going to fill all this stuff in now. First thing you have to do is rewrite this so it has a fraction exponent. So our power, what's it going to be? 2x to the what? What's that rational exponent? Think about where the root's got to be. The root's got to be on the bottom. So my fraction here is 3/4. Okay? Everyone understand how I went from radical to... Okay. So, how does my first quadrant look? Am I curving up like that? Or am I curving to the right? Or is it a branch? We have a fraction that is less than 1, but it is positive. So is it up to the right? Yeah, it goes like that. Looks like that. Okay? Does everyone understand why it swoops like that? Okay. So, the bottom, it has an even root, which means the left side does not exist. You cannot take an even root of a negative number. So there literally has nothing over here. The graph does not exist less than 0. There's no x values less than 0. So there's no worrying about, do I have to reflect it or do I have to rotate it? I'm done. Okay. So what is the domain? Let's go down through here. What's our domain there? Look at the graph. 0 to infinity. I can't take an even root of a negative number. Not possible. The range is also 0 to infinity. There is no symmetry. There are no asymptotes. Right? When is it increasing? From 0 to infinity. Right? And again, I don't care if you put square bracket or curve bracket there. Decreasing, it's not. In behavior, we only have one in the graph that it's going off of. The limit as x approaches infinity for this function is infinity, because it's going up, 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 and to the right. Okay? As soon as you get your graph, you should be able to answer all these questions, because you have it visually in front of you. Okay? It's getting that graph is where we're going to practice. Okay? All right. Let's look at the next one. This is all we're doing the rest of the period. Okay? So 7x to the 4/3. So we look at our exponent first. If it's bigger than 1, what does the graph look like in the first quadrant? We have a positive 7, so I know I'm in the first quadrant. Bigger than 1, does it curve up or out to the right? Up. Okay, so we have a up to the right branch, or arm, I should say. Okay, because that's odd, or this is bigger than 1. Bottom is odd. That means it's an odd root. Am I allowed to take an odd root of a negative number? Yes, you can. You cannot take even roots, but you are allowed to take odd roots. So my left side exists. My top number tells me it's an even function. So since my left side exists, it must be a reflection of my right side. Since it's an even function, it has to be a reflection on my right side. Okay, so you have to first check, does the left side exist? If it does, then you look at the top number and say, oh, okay, is it a reflection or is it a rotation? Got my picture. What's my domain? Negative infinity, but yeah, very good. Negative infinity to positive infinity, all reals. I've got my left side and my right side going. I have no breaks. My range, though, starts at 0 and goes to infinity. My symmetry is even. It's going to be even, odd, or none. Asymptotes, none. It increases from 0 to infinity, and it decreases from negative infinity to 0. The end behavior. Please start writing this properly. And I know they wrote it different in Algebra 2. It's a different course, so learn the different way. The limit of f as x goes to negative infinity. On this left side, where's the height going to? Going to infinity. And then we have a left side and a right side of this graph, so we're going to have two ends. On the right side, the height is going to infinity. Guys, it's an even function. They have to be the same. Negative x, positive x, same height. Okay? Make sense? You've got to get the first quadrant, or the right side figured out. Bless you. Okay? Let's try another one. So again, first things first, let's write this so that it has a rational exponent. Now you see if you can write what it looks like on the right side of the graph. Okay. What do you think? What does the right look like? Chase is doing this swoopy to the right. Is it swoopy to the right like this? What's wrong with that? If it's wrong, it's a negative, so it's got to be on the bottom. It's the correct swoop, but it's going to be reflected down here. Okay, so it is a 1/3, so you're right in the direction that's going. It's not going to go swooping up. It's going to more swoop to the right, but it's on the bottom, so it's going to go down and over to the right. Okay? So, we're looking at an odd root. So, do things exist on the left side? Yes. We have an odd function. So because they exist, it's going to be a rotation around the origin. So this guy up here is going to be like this. Imagine that that's spinning around. Okay? You got to get the right side graph first. Okay, domain. All reals. We have a left and a right side, and there's no asymptotes. The range is also all reals because it's curving left and right, up and down. Symmetry is odd. Asymptotes, nope. Is this guy increasing at all? Nope, it's decreasing. The end behavior. On the left side, is that graph going up or down? Left side. Going up. If it's going up on the right and it's an odd function, when you go to the left, I'm sorry, I put that. The left side is going up, the right side is going down. I realized I was saying it backwards. Okay? It's an odd function. It has to be opposite in behaviors. This is what you have to be able to do on the quiz for this section. And be able to state, hey, what's the power? What's the power in this case? What's the power in this function? It's not a trick question. What's the power? 1/3. And what's the constant? -3. That's what you have a question like that and a question to be able to do this. Okay? Let's do another one. We're still working, guys. Lots of time. See if you can do this all by your lonesome. Figure out what the right side of the graph looks like, and then we'll talk about the rest. What does the right side look like? Remember, you're looking at the exponent. Is it bigger than 1? Is it between 0 and 1? Or is it less than 0? That's how you get your shape for the right side. Is the shape in the first quadrant or is it in the fourth quadrant? Okay, just little steps you got to go through mentally. That's what I got. Is that what you guys got? Right? You got the swoop to the right, but it's negative, so it's on the bottom in the fourth quadrant. Okay. Does the graph exist on the left side of 0? Yes. Why? It's an odd root. Okay, good. Odd root. Okay, on top we have an even function, which means on the left side it is a reflection. So this guy is going to do this. Can you get the graph? Everyone starting to see this? What's the domain? All reals. The range. What's the range here, Garrett?
The range is 0 to -infinity.
Say it backwards. Yeah, make sure you say that in the order the numbers go. Okay, it needs to be in numeric order. Symmetry is
When 0 to bracket.
even. It would, Garrett. Good job. Zero's got a bracket. Zero's got a bracket. Okay, asymptotes. Don't have any. Increasing. -infinity to 0. Decreasing from 0 to infinity. And in behavior. As x goes to -infinity, this guy is going to -infinity. As x goes to +infinity, the right side of this graph is still going to -infinity. Again, it's an even function. The infinities or the end behavior has to be the same. I do not care if increasing, decreasing, you have the square bracket or the curve bracket. I don't believe it should be square. I'm standing my ground. Your book says curve or squared. I don't agree with it. And I'll tell Mr. Pre-Calc myself. Okay. All right. Make sense? Okay. Let's do another one. This is a nice, easy one. We're done with all the extra examples. Still the same process. Understand this exponent can be put over 1 in a second, right? You're still looking at it. This is also considered a monomial because it's a whole number. So just knowing it's a monomial and it's a whole number, you should just be able to sketch the graph like right now. So we're going to use our method that we've been doing. Greater than 1 looks like this. It's an odd number for the denominator, so the right side or the left side exists. Is it a reflection or a rotation? Reflection. Remember, 2x to the fourth is going to look just like 2x to the squared, except at the width of the problem. Okay? All right, what is the power? This is a quiz question. What is the power here? 4. What is the constant of variation? 2. Don't get that question wrong on the quiz, please. Okay. Think you're good? Let's just look at these real quick. 2x to the third. Tell me if I'm right. This guy?
No.
This guy?
No.
This guy?
Yes.
Okay. Let the record state that we all agreed it was this guy. Okay, basic cubic function. This guy is -3/4 x to the fourth. So, A, B, and upside down. Gravel looking thing, right? Okay. The last little bit here. I think you're good. You're going to practice these on the worksheet, right? Okay. With your calculator, and again, I'm not going to go through this. I want you to get your calculators out there so I can show you something. So we all know how to put this in our calculator on L1 to L2. When they want you to find the power function, So far we have done linear function and quadratic function. They want you to do the power function. So you would still type them in L1 and L2. And then, if this ever pops up, I'll show you what you're doing. Okay, so if I went to stat calc, power function is in the next window. So just keep arrowing down, and it is actually right after exponential. It says PWR regression. And I'm just going to go ahead and do whatever I had in there. Won't do it because I have a 0 in there. Power function, though, you understand where it is. And it'll give you like a, b to the x, and you fill in the formula like you did before. Okay? So you need to make sure you know how to practice those, and that's it. Okay? So we're going to practice